Let's start with the curve y equals sine x. Now, you see, when we plot the curve y equals sine x, it doesn't take us very long to discover that this curve is not one-to-one. In fact, it misses by a long shot, because for every y value between -1 and 1, there are infinitely many values of x that produce that value of y. See, this is an oscillating type of function. So you see, from our rigorous point of view, there really isn't much sense in defining the inverse sine function. Well, in a way, this is an artificial drawback that we have, because you'll also recall that when we talked about functions that were not one-to-one, we could always break them down into a union of one-to-one functions. For example, notice in the part of the curve here which I've accented, namely the domain from -π/2 to π/2, notice that on that domain the sine is one-to-one, and it's certainly onto the interval from -1 to 1. In other words, every value of the sine is taken on once and only once on the interval from -π/2 to π/2. So you see, if I disregarded everything but this part of the curve, and how could I do that? What shall I name this function? Well, why not do something like this? Let me invent a new name. Let me call this curve s sub 0 of x, where s sub 0 of x is defined to be sine x, provided that x is in the closed interval from -π/2 to π/2. Again, be very, very careful. Recall that when we talked about defining functions, we said that to specify two functions as being equal, it was not enough that the function machine was the same, the inputs had to be the same. In other words, two functions had to be equal, or to be equal, the two functions had to have precisely the same domain. So notice in this sense, there is a big difference between s sub 0 of x and the function that's being called sine x. What is the big difference? Well, for the function that's called sine x, the domain is all real numbers. For the function called s sub 0 of x, the domain is only the closed interval from -π/2 to π/2. Now again, there's nothing sacred about picking this particular interval. What I could have done was define, say, another curve, which I'll call s sub 1 of x. S sub 1 of x will be the function sine x, but now the domain will be, shall we say, from 3π/2, or from π/2 to 3π/2. In other words, notice that this portion of our sine curve is also one-to-one and runs the full gamut of values that the sine can take on from 1 to -1. And by the way, I don't have to be prejudiced this way either. I could just as easily have worked with negative values. In other words, I could have invented, say, another curve, which I'll call s sub -1 of x, where this subscript simply means I'm going in the opposite direction. S sub -1 of x might just as well have been what? The curve sine x. But now again, how are all these things differing? Only in the choice of the domain. See, now the domain would be from -3π/2 to -π/2. Again, in terms of a picture, this portion here would be fine. You see, what I can do is break up this curve that fails to be single-valued by a, not single-valued, fails to be one-to-one by a long shot, into a union of one-to-one curves. In fact, if I wanted to use some fancy mathematical language, which I'll write down just to look impressive here, but if it bothers you, ignore it completely, I guess what I'm really saying is I could have defined sine x to be the union s sub n of x as n goes from -infinity to infinity, meaning what? Take all of these pieces with these integral subscripts and form their union, and that infinite union gives you back the entire curve.